Hi, my name is Alan Chu. I'm Senior Director of Performance at Cornelis Networks, and we're going to take a look at some CN5000 performance tests versus competition. We're going to be looking at topology where it's point-to-point. We'll have two servers connected both on the CN5000 side and replicated on the NDR NVIDIA 400G side, running latency, bandwidth, and message rate tests, kind of the core suite of tests that network fabrics are measured against. So when we look at ping-pong latency, we're going to be driving our libfabric OPX provider, and that's the optimized OPX provider for libfabric provider for driving MPI routing traffic over our CN5000 fabric. We're doing it two processes across two nodes, so one process per node, driving that switch hop latency, and then really just running the ping-pong test. So let's get right into it. And here we are, just letting it chunk through. And I think what we're going to just see is that we are achieving sub-microsecond latency with CN5000. That's a tremendous feat, industry leading. And I'd say when we look at kind of what it means to the network itself, we are driving less of that straggler latency. You know, people aren't waiting now for a result, especially important across distributed computing and across large clusters of nodes. As we look at the next test we want to run, it's going to be unidirectional bandwidth. And here we're streaming data across non-blocking sends, and what we're trying to achieve is what kind of maximum efficiency will we get out of the network. Hopefully we're trying to achieve that 400 gig line rate. So as we sweep it across 1 byte to 64 megabyte message sizes, driving those larger payloads, you'll be able to see us achieve that max rate. So let's run it. And it takes a minute to chunk through the different payload sizes, but as you're seeing, we're getting to that 400 gigabit per second line rate bandwidth. Super awesome for us to get there, because all it means is that we're able to feed the compute in an appropriate manner, that it's not waiting as much for the network. Super important for bandwidth sensitive applications, and a kind of a bar for us to meet in the network. And moving along to a competitive comparison, so we're going to be running that same ping-pong latency test on the NDR 400G network. The only difference here is we are now switching out our OPX fabric, that is OPX libfabric provider optimized for CN5000 with NVIDIA's Mellanox UCX software. So as we run the actual test itself, what you'll see is our prior results on CN5000 400G and then NDR 400G on the bottom. NDR is achieving around 1.45 microseconds. That's about 50% higher than what we have achieved with that 979 nanosecond mark. And it's about 500 nanoseconds larger. That 500 nanoseconds doesn't feel like a lot, but at HPC and AI scale, it is a tremendous amount of difference. As you scale from tens to hundreds to thousands to hundreds of thousands of endpoints, GPUs or compute CPUs, you're going to see that impact compound exponentially. When we now look at message rate, we're achieving on the CN5000 side 14 million messages per second, and the NDR side is achieving around 3.9 million messages per second. This is a 3.75x delta. And what this really means is that we are able to feed the compute, we're able to feed the GPUs and CPUs at a rate that is much higher than competition, and it's eliminating that compute inefficiency that can be apparent in a solution. So, in conclusion, you know, we are at CN5000. We have a network that is delivering 400 gig throughput, lower latency, and higher message rate than competition. We have a product portfolio spanning the SuperNIC, the switch, as well as the director class switch, and it's available across all major OEMs and supporting all major compute platforms. Just at a macro level and step back, CN5000 is delivering higher performance with lower wasted cycles and less compute nodes. Thank you.